Today's project's going to be this 350 Chevy block, and I'm boring and stroking this to a 383. So I got to come in here and do a little bit of clearancing inside here for the rotating assembly to fit. And there's a few different ways to go about it, and I'm just going to show off real quickly how I do it. Now this engine is for obviously a customer of mine, and he showed up yesterday and said that he stumbled upon my YouTube channel. Now I usually don't really promote my YouTube channel on outside discussions, and he just randomly fell upon it and called me up and said, hey, I just found your channel, I've watched all your videos, they're awesome, and I appreciate that. So Greg, if you catch this video, this one's for you, since that's your engine block. So let's get into it. So once it's clamped on the machine, I run my dial down the mains and I just true it up to the machine. Once it's trued up and clamped down, there's a couple of ways to find the center of this housing, and I just typically use my edge finder. This isn't a super high precision operation. With the edge finder, we come and we find the first edge. Just like so. Zero or y-axis. Then we can move to the other side. Once it breaks free, a little heavy there. Once it breaks free, we take this number and we divide that by 2, and that'll be our center. Now I'm going to come in here and I'm going to touch this inside face where the thrust bearing goes. My edge finder just broke. Now on my edge finder, I got a 200 thou diameter point here. So when we touch the edge, we're actually out from that edge, whatever the radius of your tool is. So that'd be 100 thou on this one. So when we come on the readout, we do have a couple options. We can either just push the X and call that -1, or in the case of, let's just say we just had some random number here, like that. Ooh, I wish my table was that long. We can actually zero the readout, move X over till we get to 100, and zero it like that. It basically just depends on your mood. This 3/4 inch roughing end mill is the tool I typically use for the small block Chevy reliefs. We just grab that up in our spindle. And as for my locations, quite some time ago, I mapped out and sketched out a drawing of where my locations are going to be. So we just crank the X over, and then the Y. I don't know if we can see that, but where the original notch in the casting is, we're lined right up with our end mill. So we crank the end mill on, and I like to plunge this off. Now sometimes there's a lot of metal removal, and other times there's not. In this case, we just had a tiny little nick. And we just move on to our next location. Now sometimes these castings don't actually have a lot of material to remove out of there, and sometimes they do. So far we just got nice little touches right here, and my little machine marks are right in those factory casting reliefs. And this side's done. We'll now move on to the other side. And as you can hear, this side had a little bit of a heavier cut. And just like that, this milling operation is finished. Now I can get this over to my workbench and we're gonna mock this up and we're gonna check just to make sure everything fits. And so we got our notches machined. And if we look into this side here, the first side we did, I don't know if we can see it, but we don't exactly have a whole lot of material contact right here. But when we come over onto this side right here, we got some pretty deep notches. Now, my numbers worked off the center line right here. So the distance from this notch where I machine and this notch where I machine are gonna be the exact same distance off center line. And this is just our casting shift that's showing, you know, more contact here than contact here. Now, what is gonna happen when I mock my rotating assembly up is we're gonna find that we got a lot more room down here than we do up here. And the reason for that is because I'm coming in here with an end mill and I'm just doing a straight plunge. This edge right here is actually kind of on an angle outward. So our end mill is actually contacting here far more than it is up here. Now I got my drawing all mapped out so that I'm taking off the minimal material that my rotating assemblies, they just fit. And the reason is because if I go in a little further and plunge in, because we're taking so much off the bottom here, this is where you'll break through when you're doing straight plunging or cutting or milling with the machines. Versus when we come in here with our little grinders, we're grinding heavy up here. We have the potential of breaking through anywhere here. So I come in, I plunge straight, I'm gonna mock it up, I'm gonna find I got sufficient room here, and I'm probably gonna be just a little tighter than what we're looking for. Now we're usually looking for a 16th or 60 thou or 1.5 millimeter for you metric guys that insist on using metric on an Imperial engine. And what happens is I end up having to relieve up here sometimes. So we're gonna mock it up and we're gonna see how it fits. Now for this, I got a set of bearings that I have just for the shop, just for this application. And I got an old 350 Chevy piston where I've pinched the bore a little bit just so that it retains the wrist pin on its own. And I used a crank and the connecting rods we're putting in the kit, but I try to use as minimal as the parts that we're using, just as not to mark them up. We'll put a little bit of oil on the bearing here. We're gonna slide this piston in. We're gonna make sure we got the connecting rod oriented the right direction. A little bit of oil. We're just gonna zap that on and we're gonna have a little peek. I better get a flashlight for this one. So I'm assuming we can all see that pretty clearly, that I got plenty of room in there. And this is the side I removed very little material off of. Like this one here, I mean, I just nicked the bottom. But we definitely got plenty of room. We want to make sure the bolt clears right here as well. And in this block we do, some of them don't. So we got plenty of clearance. Now I'm just gonna take that and I'm gonna pass this through all of them just to make sure that it all fits right. All right, so I've gone and checked everyone, and we got clearance all the way around. And I just want to show on this side how that bolt really tucks into that little notch that we made. Where can we? There we go. See how that one just really fits right in there? And on the other side we had lots of clearance. So the other side we probably wouldn't even have had to cut anything, and this side we definitely had to. But as you can see, we definitely got adequate clearance, and it's like that right across the entire side. So that's looking pretty good. So I went in there with my little soft sanding rolls and I broke all the sharp edges around the bore and these little machined areas I just put in. Now this is a freshly machined block, and so when I bored this out, we get a little bit of nasty at the bottom here. So I always come in here and I just buff these out so that they're nice and rolled off. Now, even though we got this rotating assembly fitting in the block the way I want it, we got a little bit of more work to do before I can say I'm finished on this clearancing. And as what I'm going to do now is I'm actually going to pressure test this block. See, we took a little bit of material out of here, and you never know if you broke through or not, and I don't like taking chances. So since I took out so much material off this side, and I barely took anything off this side, so I'm not worried about this side, but we took a good munch out of this side. So I'm actually going to pressure test this side just to make sure we didn't break through here. Now, what I got here is a well-fitted plate with a thick rubber gasket. And it blocks off all the cooling passages, and it plugs the holes. The threaded holes on the deck of a small block Chevy all go through into the cooling cavity. Now, normally I like to do the clearancing on the block first and then test it. That way there, if I did manage to break through, I didn't just waste a whole bunch of time and work and money. But you know, I work alone and I get busy and distracted, and sometimes I either A, forget, or B, my order of operation gets changed up just because I got, you know, multiple jobs to pass through a machine and I don't want to stop. So this block here has been line honed, and I send that out for line honing, and that goes to another shop. So I got to drive all the way down to that shop, and then I sit around and shoot the shit with the boys for about a half hour, and then I come back, and a few days later they call me up and tell me my block's done, and I got to drive all the way back down there, and I shoot the shit with them for another half hour or so, pay for my block, and then come all the way back. And then now that it's line honed, it goes up on my boring machine. I get it all squared up. I deck it, I rough bore it, chamfer it, and whatever else I might do to it. And then it goes into the honing machine over there. But, you know, this time we're doing the clearancing last. And, you know, I'm not too worried. It's been a long time since I've windowed a block. My procedure has been, you know, pretty effective for me. And I'm pretty confident that this one's gonna pass, but it's just one of those things I gotta know, because if I sent this out and that thing actually did leak, I mean, not only is that a big pain in my butt, but you know, that's a strike against my quality. And oh, that's the wrong gasket, and I can't have that. There we go. So I just test every single one after I've taken material like that out, just to be safe. And I mean, I got the tools, so, you know, why wouldn't you? If you got the tools, why wouldn't you? That's nothing but laziness if you got the tools and you don't go through it. And then if it does leak, because you didn't test it, you didn't know until it's in buddy's car, I mean, kind of suits you, right? All right, so we got all the passages closed off. We got all the plug bores closed off. We got the drain plug closed off, and this is where the water pump pushes the coolant through. So we got that plugged off, and this is where we put our air in. So I pop on a pressure regulator here, grab my air line, and we crank around 45 psi of air into these things. We got about 42 on this one, and it's just like checking, you know, a punctured tire. And I just come where I just ground right here. Now this block has already been magged and pressure tested before I started doing anything, so I know the block itself's good. I just want to check where I ground. and or milled, I mean. And you know, my test says that we're good. Now if we were leaking, there'd be a whole bunch of little bubbles spewing out of there. So that's it, just this couple of minute little test. That's all I needed. And I'm only doing it on this side because this side's the side I took all the material off of. When we come to this side, I mean, I just nicked it, so I'm confident. And let's see if we can replicate a leak. So here we go. We come to this plug here. Can we see that sizzling out? So if we come down to this plug on the side here, there's no sealant on there, so we got a little bit of a leak. That is what a leak during a pressure test is going to look like. That's what they look like. Other than that, we got no leaks coming out, so I'm going to say we're good to go. All right, well, that's how I go about making my rotating assemblies fit into my small block Chevys. And you know, I do a lot of 331, 347 stroker Ford engines too. You know, we make them out of those little 289, 302 blocks. And I got the same procedure, except the way the sleeves protrude out the bottom of the block. After I put my clearance notches in them, I actually don't have to pressure test those blocks because those machine marks are absolutely nowhere near the cooling cavity. So we can skip that step altogether. But you know, it's a good idea on these 350 blocks because you never know if you poke through, you never know where that casting is, and it could just be the slightest tiny little pinhole that you didn't see it with your eyes, you didn't think you took that much material out, and next thing you know, it's never happened to me yet, but next thing you know, it's leaking inside your car, right? You're getting coolant in your oil, and that's no good. It's been a long time since I poked through a block or cylinder head casting. Like when I port cylinder heads after I've done my porting, I got a pressure testing bench, and I'm gonna throw them up there on the pressure testing bench just to make sure I didn't break through. And I mean, it happens every now and then. You get in, you start doing your work, you get in your groove. I mean, some of these heads I've ported dozens and dozens of. I got my routine, and you throw them up on that pressure tester, and boom, you got a little sizzle out of one of the ports. And it's like, dang, you know, I thought I had it. And you know, it doesn't happen too often, but I pressure test every single one. I can't take the chance. So anyways, I better get back to work. There is just tons of it here. Thanks for watching, guys, and I'll catch you later.